It's finally time to create the enemies. One of the core elements when making enemies is AI. Depending on how you implement it, the complexity can vary as time goes on. For really simple cases, you can make it with simple, nested if-else statements. But as the scale grows and the AI becomes more complex, while you could still make it this way, the code becomes messy and difficult to maintain later. So to solve this problem, one alternative approach is to use Finite State Machine, which defines behaviors based on states. I've been creating enemy AI using FSM until now, but this time I want to try something different. Before introducing the way how I made the enemy AI, let me explain the enemies I am currently making. It is a researcher infected by some unknown organism from an unidentified source. They are slow moving, perform melee attacks, and they respond to sounds made by the player. And when they detect the sound, they move toward that location. They can also identify nearby players, and if a player enters their field of view, the enemy will chase the player. And if the player is within attack range, they will attack. I could make these enemies using FSM again, but I've been frustrated with several things about this approach. First, it's visually hard to understand what states the enemy is currently in and what conditions are met to transition to another state, making debugging extremely difficult. I could see the current state through list and text in the inspector, but checking this while testing the game was too cumbersome. Second, as more states are added to the AI, managing the FSM becomes exponentially harder. Every time a single state is added, you have to consider all the existing states while working on it. Third, this is a fundamental limitation of FSM. Since FSM operates based on the current state, it's difficult to implement complex behaviors. For example, let's think of a situation where you need to make an enemy that can detect sounds while patrolling and while idle. To create this with FSM, you need idle and patrol states. You'd have to include sound detection in each state. This simple example shows that it could produce lots of duplication. So while thinking about and searching for alternatives, I discovered this behavior tree. While searching around, I found a Unity package called Behavior Designer and learned about behavior trees through it. First, let me clarify that I have no relationship with the Behavior Designer package. I'm just a solo developer who wants to make games more comfortably. When I first purchased it, I didn't understand the true value of behavior trees. I just liked how it visually showed the current state well, so I bought it. But as I actually implemented AI with it, I fell in love with behavior trees. I thought I would start with the simplest features to learn, like random movement. I took the scripts I use with FSM and modified them slightly to fit the behavior tree interface. It took some time, but through multiple iteration and testings, I gradually learned how to use behavior trees. The demos provided the package was also very helpful. The real power of behavior trees shows when dealing with how the enemy detects a player, like detecting sounds, moving toward the sound source, and chasing the player if they are within line of sight. For chasing targets based on sound, I'm thinking about the noise system where noise can be generated by the object movement or events. When enemies detect noise or sound, they move toward the point where the sound originated. So during the chase, when the player runs away far enough that the enemy can no longer detect the sound, then the enemy will stop the chase. But otherwise, the enemy will keep chasing the player. Later, I think using this system, we can create a system where the player can lure enemies with sound. And the enemy basically has two types of FOB. One emulates its primary vision, so the range is longer than the other, but has a narrow angle. The other one is for side vision, like how humans and other living beings can perceive objects on their sides. So if we combine these two systems, basically if the enemy has no targets in their vision, they will set a target if they can hear a sound and start chasing it. And while they are chasing, if they spot the target in their vision, they will switch to visually tracking that target. With this combination of vision and sound detection, I think we can create more natural enemy behavior. With FSM, every state would need to include sound detection AI and player detection within sight. But with behavior trees, we don't need this kind of work at all. You just create each as a tree node, and you are done. I made each tree node run in parallel. This way, the AI is always detecting sound and checking if the player is in sight. When either is triggered, it performs that action. Also, we can make this kind of AI easily. For example, if the enemy first detects a sound and moves towards it, but discovers the player while moving, then the enemy will chase the player instead. This would be difficult to implement with FSM. In this situation, adding the attack functionality when the player is within range was also a piece of cake. Using behavior trees made it incredibly easy to handle simultaneous events. Another great aspect was related to testing. You can activate only the nodes you want to test. You can finish testing specific behaviors first, and if they work well, you can integrate them with other behaviors. This is quite different from FSM also. So that's how I explain the process of creating enemy AI using behavior trees. As complexity increases further, the drawbacks of behavior trees might appear, but I'm really satisfied with it so far. Some say that behavior trees are hard to build well because there are many simultaneous events to handle, but I actually find it more intuitive than FSM. Maybe it's because behavior trees feel more similar to how humans think. If my mind changes, I will talk about it later. That's it for this video. If you enjoy watching this video, please subscribe to this channel. I will keep working on this project and I will share even more interesting devlogs next time. Bye!